Alright, so in this video we're doing something that you may or may not have done before, which is called factoring differences of cubes and factoring sum of cubes. We're going to do both of these two methods in the same video. If at any point you need to pause and rewatch some of it, that's totally fine. We'll be back when you hit the play button again. So, first off, we've got a rule for difference of cubes. So this is difference of two cubes. So notice it's very similar to difference of two squares, minus in the middle, two pieces, but this time I have cubes. And then it's going to factor into a minus b times the quantity a squared plus ab plus b squared. This is just one of those things you're going to have to memorize. It takes time, but if you practice, you'll get it. So what I want to do is apply this pattern to 27x cubed minus 8 and factor it. The very first thing we need to do is to figure out, alright, what is our a cubed, what is our b cubed? And then instead of the square roots, we're going to do the cube root, because cube root and cube cancel each other out. So, based on this pattern, a cubed is 27x cubed. No big deal. And then based on this pattern, b cubed is 8. Just like the difference of two squares, the minus is not part of the problem. The minus is only part of the name. All you need for b cubed is the number, 8. If you put the minus there, it's going to come out wrong. Don't do that. Okay, so now, again, like I just said, cube root and cube cancel each other out. So I'm going to do the cube root on each side. Now, square roots are probably easy for you, but cube roots might be a little challenging. So I'm going to show you in just a second how to do cube root on your calculator. Remember, it only works for numbers. It will not take care of the variable for you, but it'll at least get you started. So, cube root cancels out with cube. So this means that I have a equals. Now, I want to do the cube root of 27. Now, I know the cube root of 27 is 3, but just to show you how to do it in the calculator, what I'm going to do is go to my main screen. If there's anything else in there, clear it out. So go ahead and hit math. And the cube root is option 4, just the very first thing. And it will give you some parentheses. So I'm going to just put my 27 in there, and you need to close the parentheses up. So the cube root of 27 is 3. So if you struggle with your cube roots, don't be afraid to use the technology. So cube root of 27 is 3. And then again, cube and cube root cancel out, so a is 3x. Alright, now, again, cube and cube roots cancel out, so I know that b is equal to the cube root of 8. Use your calculator if you need to, but I don't. So the cube root of 8 is 2. Great. Now that we know a and b, everywhere in our pattern we see an a, I'm going to put in a 3x. Everywhere I see a b, I'm going to put in a 2, and that's going to be our answer. So our pattern says it's a minus b, so we end up with 3x minus 2. And then it's a squared plus ab plus b squared. So a squared, that's 3x squared plus 3x times 2 plus 2 squared. I'm just plugging into my pattern. So now what I want to do is clean this up as much as I can. So 3x minus 2 just stays. 3x squared is 9x squared. Remember to share the power with both pieces, the 3 and the x. 3x times 2 is 6x. And then 2 squared is 4. And anytime when you're doing these sums and differences of cubes, this piece right here, this trinomial, is not going to factor. So this is the lowest factored form for this difference of cubes problem. You can verify this by using the box or a modified FOIL, whatever you prefer. Let's keep going. This is talking about factoring the sum of cubes. The pattern is pretty much the same. We have two pieces, both cubes, this time plus in the middle for sum. It's a plus b times a squared minus ab plus b squared. Again, that rule seems a little complicated. You're just going to have to take your time and get it memorized. The more you practice, the better off you're going to be. So let's apply this rule to this problem right here. A at 8x cubed plus 27. Our first thing is to determine what a cubed and b cubed are. So a cubed is going to be 8x cubed based on this pattern, and b cubed is going to be 27 based on this pattern. Not too bad. Now what we need to do is cube root each side to find what regular a is and what regular b is. Once we know those, we're just plug into our pattern and we're done. So cube root each side Again, cube and cube root cancel out, so I'm just left with a is equal to cube root of 8, we already know is 2, and then the cube and cube root cancel out, so a is 2x. So everywhere in my pattern I see an a, I want to replace it with a 2x. Let's do the same thing for b. Doing cube root on each side, so cube and cube root cancel out. So I'm left with b equals, and then the cube root of 27 is 3. So everywhere I see a b now, I'm going to replace it with a 3. So plugging into our pattern, I have 2x plus 3, and then 2x squared minus 2x times 3 plus 3 squared. Now I want to clean this up as much as possible. 2x plus 3 will just stay the same. 2x quantity squared is 4x squared, minus 2x times 3 is 6x, and then this becomes 9. Again, this trinomial is prime, it will not factor anymore, so this is the lowest factored form of our original problem, 8x cubed plus 27. This was pretty easy, just plugging in the pattern, no big deal. Let's crank it up a little bit. Alright, so here we have a cubed, 2 pieces, and minus in the middle. So my very first instinct for this particular example is that, hey, we need to do difference of 2 cubes. So what I would suggest until you get it memorized is write out the rule or the pattern every single time. It was a cubed minus b cubed equals a minus b times a squared plus ab plus b squared. Okay? But for this particular problem, we're saying the x minus 1, the quantity cubed, minus 125. Well, very similar to what we've done in previous videos. Instead of x minus 1, I'm going to substitute in a different variable to make this problem look a little easier. So everywhere I see an x minus 1, I'm going to replace it with a y. You use whatever variable you like. Okay, so rewriting my problem now, I have y cubed minus 125. Okay, so this is pretty easy now. So just doing this, a cubed has to be y cubed, and b cubed has to be 125. Well, I don't want a cubed and b cubed. I want regular a and regular b. That way I can just plug into my pattern and be done. So I'm going to just take the cube root of each side. Again, cube and cube root will cancel out, so I'm just left with a is equal to y. So where I see an a, I'm going to put in a y. And then cube and cube root will cancel out again, both sides. So I'm just left with b is equal to 5, because the cube root of 125 is 5. So now plugging into my pattern, I have y minus 5 is equal to y squared plus 5y plus 25. Okay, and I've skipped a little bit of steps here. Okay, I cleaned it up in my head. If you need to show all the steps, you do that. Whatever's best for you. Now, again, our problem, though, doesn't have y in it. It has x minus 1. So everywhere I see a y, I'm going to replace it with x minus 1 to finish up the problem. So I have x minus 1 minus 5 times x minus 1 squared plus 5 times x minus 1 plus 25. Okay? We need to clean this up as much as possible. This might take a little bit of scratch work. That's okay. Don't get discouraged. Just power through it. So, negative 1 and negative 5 is negative 6. I end up with x minus 6. X minus 1 squared. If you need to do scratch work here, you can. But it just comes out to be x squared minus 1. Okay? Actually, I did that wrong. That's my fault. X minus 1 quantity squared is x squared minus 2x plus 1. And then finally, this piece becomes 5x minus 1. That's distributive property. So we have plus 5x minus 5, and then plus 25 just falls down. Okay, now we need to clean up as much as we can. So x minus 6. X squared is the only squared term here, so now we need to combine regular x's, so negative 2x, positive 5x. That's 3x. And then finally, combine our constants, so 1 negative 5, and positive 25. So we end up with 21. And then that's our final answer. And that's it for this problem.